All right, compare is 3/4 between 2/3 and 5/6. Whenever we have comparison problems, it's easier when the denominators are the same size. I'll give you an example. Let's say that we have a pizza that's cut into fourths, okay? And all of these pizzas, let's assume they're the same size. If I said something like is 1/4 between 2/4 and 3/4. Okay. Now, if you look at this, 1/4 is less than 2/4, and it's also less than 3/4. And so this amount is not between 2/4 and 3/4. It's clearly not between them. What makes it easy to see this is that all of the denominators are the same. So in other words, if you have a pizza, all of the slices are the same size, so it's easier for comparison. In the situation above, the denominators are not the same. You have 4, 3, and 6. So in order to make it easy to compare, we have to convert it so that they all have a common denominator. Okay, so we need to make a list of the multiples of the 3s, the 4s, and the 6s. Let's generate that list using our multiplication chart. As you can see, 12 is in each of these lists, and if we kept going, we'd find another number, but 12 is the smallest one, so we're going to go with that one. So now what we're going to do is convert each fraction so that the denominator is 12, and it's easier to compare. If I look at the 4s, I can see that 4 can be multiplied to turn into 12 by multiplying 4 times 1, 2, 3. 4 times 3 is going to get me to 12. And whatever I do to the denominator, I have to do to the numerator. In other words, whatever I do to the bottom, I have to do to the top. So 4 times 3 is 12. 3 times 3 is 9. Okay? We can apply that method to turn 3 into 12 as well. 3 times 1, 2, 3. 3 times 4 is going to get me 12. All right? So 3 times 4 is 12. 2 times 4 is 8. One more time, you can see that 6 times 1, 6 times 2, sorry, that was my phone. 6 times 2 is going to get me to 12. And so 5 times 2 is going to get me to 10. Now we can compare it. Okay, the smallest one is 8/12. The next one is going to be 9/12. And the last one is going to be 10/12. As you can see, 8/12 is 2/3. 9/12 is 3/4. And 10/12 is 5/6. So the question of is 3/4 between 2/3 and 5/6? The answer is yes. Yes, it is between them because 3/4 is higher than 2/3 on the number line. It's further up, but it's lower than 5/6 on the number line. It would be further down, which makes it right in between. All right, so when you add fractions and the denominators are like each other, it's really easy to do because we're adding parts that are of the same size. So for example, 1/3 plus 1/3, your visual, again, we'll work with pizzas. Let's just assume that I'm a better artist on the iPad and that these are the same size. As you can see, 1/3 plus 1/3, you still have slices that are in thirds, that size, but we have 1, 2. 2/3 of a whole pizza when you put it together. So the denominator stays the same, and all you have to do is add the numerators. What complicates the situation is when your denominators are different. So we're going to have to find a common denominator, and then we can add or subtract them. To find a common denominator, we're going to make a list of multiples using our multiplication chart. As you can see, the least common multiple that we can use for our common denominator is 6. So we're going to go ahead and put a 6 in the denominator of both fractions. And then we are asked to subtract, so we know that we're going to be using some subtraction. Now we need to convert. In order to go from 6 to 6, we're really not going to change anything. In other words, we just multiply times 1 in the numerator and in the denominator. So 5 times 1 is going to give us 5/6. That doesn't change. But to go from 3 to 6, we're going to have to multiply 3 times 2, and that gives us 6. 1 times 2 gives us 2. And now we have equivalent fractions, okay? And we know that the denominator is going to stay the same, and then 5 subtract 2 is 3. We're going to look at it in picture form real quick so you can see why it stayed the same. All right, so for 5/6, you have 5 slices out of 6, okay? For 1/3, you have 1 big slice out of the 3 slices. So when we found our common denominator, we made 1/3 into sixths. So I'm going to cut each slice. So now we have 6 slices, and you can see that 1/3 is actually the same as 2 sixths. Okay, when you took it away, if you took these 2 away from this right here, that really only leaves you with 1, 2, 3 left. So that's why we have 3 sixths. All right, so if you have a 1957 Chevrolet Corvette and it increased in value by $124,000 over the course of 62 years, what would the average increase in price per year actually be? Guys, I didn't just make these numbers up. Depending on who you go to evaluate the car, it started around $3,000 in 1957. Remember, in 1957, a dollar was worth a lot. You can get like a loaf of bread, a gallon of milk, and just a whole bunch of other stuff for a dollar. So it was about $3,000 back then. Nowadays, or actually I think it was back in 2017, that's when you'd pay $124,000. And what we're asking is, okay, if the price increased by the same amount each year and you split it up over the course of 62 years, how much would it have increased by each year? Are we adding to figure this out? Are we dividing? Are we subtracting? What are we doing? Add, subtract, multiply, divide. Your clue is split it up. When you split something up, you're separating it. That means division, okay? 124,000 divided by 62. You do that, you're going to get the amount that it changed per year. In other words, you're going to find the average increase in price per year. Let's do the division. Okay, 62, too big to fit into 12, but it can fit into 124 twice. 2 times 62 is exactly 124, but here's the thing though, you got to bring down your 0, bring down your 0. 62 does not go into 0, so you're going to put 0 times. 0 times 62 is 0. You're going to subtract, and now you're going to bring down your next one. 0 does not go into 62 again, so you're going to multiply 0 times 62. Voila, you get 0, but you still have one more to bring down. 0 does not go into 62 one last time. 0 times 62 is 0, and when you subtract, you're done. There's nothing left to bring down. It would seem that the average increase in price per year was $2,000, ladies and gentlemen. All right, so we have a vertical number line, and you also have the numbers that are just given to you. If you look closely, they tell you Hawaii is 12 degrees Fahrenheit, North Carolina is negative 38 degrees Fahrenheit, and so on. So we don't actually have to estimate based off of the number line itself, although we could look at it to verify and see, oh yeah, 12 is just above the 10 right there, and negative 38, as the temperatures get closer and closer to 0, you can see 80, 70, 60, negative 50, negative 40, and then just above it is negative 38. So it is accurate. All right, now in the question, they ask us to enter the difference in degrees between the record low temperatures in Hawaii and South Dakota. Difference means subtraction, okay? So we're going to subtract. We know that, so I'm going to put my subtraction. Hawaii, which is 12 degrees, and South Dakota, which is negative 58. So we're going to subtract a negative. And hey, wait a minute, hold on a second. I see a double negative. Those are neighbors, so you're going to actually turn that into addition. Remember, a double negative means the opposite of negative, which is positive, or adding it. Now 12 degrees plus 58 degrees is equal to 70 degrees. That's all you have to do. I'm going to throw another one in here just for good measure. If we compare Hawaii again, that's 12 degrees. We know that. North Carolina, if you look there, it's negative 38 degrees. So the difference, we're going to subtract between 12 degrees and negative 38 degrees. Those are the two locations. Once again, you can see a double negative means the opposite of negative. That's neighbor rule. Turn it into a positive sign. 12 degrees plus 38 degrees is actually going to give you 50 degrees is the difference. Okay, and that's it. Okay, so we're going to do one more. Enter the difference between the difference in degrees between the record low temperatures in North Carolina, which is negative 38 degrees, and difference means subtraction. We're going to find the difference between that and Montana, which is at negative 70 degrees. So again, we have the neighbor rule, but this time you have a negative 38 and a positive 70. It does turn into addition, of course. Because the signs are different, you're going to subtract the numbers. 70 subtract 38 is 32 degrees. And it's going to be positive 32 degrees because the positive number 70 is larger than the negative number 38. And so the positive is going to win in this battle over positive and negative temperatures. The difference is 32 degrees.